This is the screencast for section 5.5, example 2. We're going to use the trapezoidal rule again, except this time we're going to use it with data points, which actually can be a little bit easier sometimes. And we're going to average some temperatures in example 2. An observer measures the outside temperature every hour from noon until midnight, recording the temperatures in the following table. So I called noon times 0, and then midnight 12 p.m. I guess, or 12 a.m., whatever. What was the average temperature for the 12-hour period? So the average temperature is what we're trying to find. Okay, so I put all my data points in L1 and L2, the time in L1, the temperatures in L2. I stat plotted that and I did a zoom 9. So the average temperature then would be kind of the average value that we learned in the previous section. 1 over b minus a times the antiderivative from a to b of f of t dt. But we don't have a function, so we still need to calculate the area in a different way. Well, trapezoidal rule will do that for us. So I'm going to, instead of this being a nice fluid curve like that, I'm going to connect every single data point with one side of my trapezoid that I'm going to use. And then I can divide this into all the pieces necessary to make those trapezoids. Each trapezoid has a width of 1, and then I take the heights, so that first height, the initial height is 63. I'm going to divide that one by 2. Every other one gets a whole 65, a whole 66, a whole 68, etc. And then 55 divided by 2 from the last example. And then, of course, I'm finding the average value of that, so I need to multiply by 1 over b minus a. Well, in this case, it's 12 minus 0, so a total of 12 hours. So I get that the area under the curve is 782, so if I added up all the temperatures, or all the cumulative temperatures, I'd get 782 total degrees. So the average temperature, if I divide that by all 12 hours, is 65.167 degrees. Now that visualization, doing the stat plot, isn't necessary. If you understand that these data points are going to create trapezoids and how they create trapezoids, you do not need to create this picture. You don't even need to put it into your calculator. So in the now try problem number 7, that's what I'm going to do. I'm going to use the function's values with the appropriate table in the trapezoidal rule with n equals 6 to just approximate the area, signed area, from 0 to 6 of f of x dx. So I'm not finding the average value like I was in example 2, I'm just finding the area under these data points. So I know that each of these f of x values represents heights, or well, sides of these trapezoids, so they're bases. So I can use a width of 1, and then 12, the first base, is only going to be used once, so I need to divide that by 2. Every other one in the middle is going to be used twice, so I get to use whole values for those. And then I need half of 18 because it's only going to be used once as well. And I get about 74 square units.